Hi everyone, let's start with atomic structure today. This is the most important chapter for your MSET, JEE, NEET, everything. Yeah. So at least a couple of questions are expected, definitely. Yeah. So be very careful doing these formula first. So I hope you can see all these formulations, very, very important formulae, which has been confined to you in a very short notes. Please copy down all these formulae in your notes. I'll be seeing it tomorrow. Okay. Next, so to start with, this is mass of the electron. Mass of electron is 9.1 into 10 power minus 3 kilograms. Then mass of protons is 1.67 into 10 power minus 27 kilograms. Whenever it is being asked to you, you should be ready with these mass of electron, charge of proton, all these things given here. And then E equals to mc square. That is what we know already. E equals to mc square and energy is equal to h nu. E equals to h nu. And h nu here, you can write it as hc by lambda because nu is c by lambda. Now, how is nu c by lambda? See, speed is distance by time. Here in the corner, I'm writing here, speed is distance by time. Speed is considered to be the velocity is equal to distance is lambda into 1 by time. 1 by time is frequency. So frequency is equal to c by lambda. Why am I writing it as c? Because c stands for the speed of the light. V is nothing but the velocity. I am converting it to be a speed of the light because for any electromagnetic spectrum, what we talk about, the electromagnetic waves, we generally take the speed as speed of the light. In case it is not told to you that this is the speed, you can take this. So C by lambda, nu is equal to C by lambda. So in the place of nu, I am putting it here as C by lambda. So MC square is equal to HC by lambda. CC gets cut. MC is equal to H by lambda. So lambda to the left side, lambda is H by MC. M into C. C is the velocity, right? So mass into velocity is nothing but momentum. So MC is nothing but your P, which is momentum. Lambda is equal to H by P, where H is your Planck's constant. H value is 6.626 into 10 to the power minus 34. That is your H value. Please write it down. H is 6.626 into 10 to the power minus 34. So that would be your H value by P, which is your lambda value. This is also your de Broglie's wavelength. And then you have something called as angular momentum. Angular momentum L is denoted by MVR. MVR, that is your angular momentum. And you have MVR, angular momentum is NH by 2 pi. Angular momentum is NH by 2 pi. Also, orbital angular momentum you are given here as under root L times L plus 1 times H by 2 pi. So this also is very important for your formulations. And yeah, then we come up with the photoelectric effect. What do you mean by photoelectric effect? In case you have a metal plate and there is a striking photon, metal plate are with atoms in it, right? Each and every atom has the tendency to lose the electrons as they are metals. So therefore, as the energy is being hit here, as the photon is transferring onto the plate, is hitting the plate, atoms in the plate start releasing the electrons because they gain energy, they gain some kinetic energy, they release the electrons. As they release the electrons, how long it can hold? What is the frequency, threshold frequency, h nu naught? See, the total input energy is h nu, right? This is what we have seen, energy equals to h nu, this one here. Energy is h nu, so energy, total input energy of the photon is equal to the output energies. And what is the output energies? This is also called as work function. Work function. Please write this down. H nu naught is work function. H nu naught plus kinetic energy or the binding energy plus kinetic energy. Binding energy is the energy required to bind the electron into the aura. Okay, into the atom's aura. That is what is your binding energy. And then when electron is being ejected out, because the electron is being ejected out, electron comes out with some velocity, which is v here, so which is kinetic energy. Each and every moving particle has got kinetic energy associated with it. So E is equal to mv, kinetic energy is half mv square. So photoelectric formula, h nu equals to, the h nu is the input input energy. Write it down clearly. Input is equal to h nu naught plus kinetic energy. Then you have the series to talk about. So whatever series we have, the electromagnetic spectrum we have here, electromagnetic spectrum, read my instructions, visible under X-rays and gamma rays. I will write it down here. You can write it separately. Read my instructions, visible under X-rays and gamma rays cosmically. Okay, so here as you move towards the right side, it is frequency is more here. Here frequency is less. Frequency less, which implies your amplitude is more. Right, so now read my instruction. As you see this R, M, I, V, U, X, gamma, and C. So read stands for radio waves, M microwaves, I infrared waves, visible, ultra waves, and X-rays, gamma rays. Okay, and these are the cosmic rays. This is an order of your electromagnetic spectrum, which you can note down. And then coming up with, I'm just moving a little fast, bache. Please, you can pause it and then you can take it down. You don't need to run after me. You can pause and then you can take it down. And HC, whenever you see HC, you can use this tip. HC is 2 into 10 to the power minus 25 because H value is 6.626 into 10 power minus 34 and C value is 3 into 10 to the power 8 meters per second. When you multiply that, that is going to be 2, roughly around 2 into 10 to the power minus 25 is HC value. Wherever you see HC value, you would use that. And H by 4 pi. And why are we using H by 4 pi? This talks about the Heisenberg's uncertainty principle. Heisenberg's uncertainty. Heisenberg's uncertainty. What do we mean by that? Delta X into delta P. Change in momentum. Delta P is change in momentum. Delta X is change in the position is always greater than or equal to H by 2 pi, H by 4 pi. H by 4 pi. So this H by 4 pi value, not every time you should, keep on doing it. You can use the value of H by 4 pi as 0.52 into 10 to the power minus 34. Okay, so please write this also. H value, H by 4 pi can be written as 0.52 into 10 power minus 34. These are all the pre-calculated values what we have. So once you are thorough with these things, we can move on with the next ones. Now we have spectrum. Okay, you have Lyman series, you have Balmer series, Bastian series, Brackett, Fund, Humphrey. Okay, LBP. B, LB, PB, P. All this, you can just remember this way. Lyman, Balmer, Bastian, Brackett, Fund. Now, if these electrons have been moving into the first orbit, then it is UV. Second, it is visible. Third onwards, it is infrared. Fourth onwards, 4, 5, 6, 7, so on onwards, it is infrared. P fund, which is P silent, fund series, 5 onwards it starts, N is equal to 5 onwards it starts, and Humphrey starts from 6 onwards. These numbers, you should remember these numbers as well. Now coming up with this radius, the second set of the question. See, please make them like these sets as I have written. The first set of the things is your charge value and mass value. Second set is the Chutput formulae. Lambda is equal to h by d Broglie wavelength, E is equal to mc square, angular momentum, all these Chutput formulae jo bhi hai, your set 2. Set 3 is your photoelectric effect I have given. Set 4 is your series, Lyman, Balmer, Bastian, Brackett, Fund, and Humphrey. Set 4. And then you have set 5 here as radius of the nth orbit. So whenever we talk about the radius of the nth orbit in any given atom, radius is equal to n square h square by 4 pi square n square into z. So do remember these, and in case the direct question is asked to you, you can use that. Otherwise, any numericals is asked to you, 0.529 by n square by z. Armstrongs. Armstrongs is 10 to the power minus 10 meters. So radius is given to you in this, or 52.9 n square by z picometer also you can do, or remember it as 0.529. It is easy for your calculations always. And then radius of the nth orbit we have, and then energy of the nth orbit, where here, if as you can see, n stands for the nth orbit, z stands for the atomic number. Z is your atomic number. Okay, now energy of the nth orbit is minus RH into 1 by n square, where RH value is given to you. You don't need to remember that value, but yes, in advanced or something, you may have questions based on the theory part of it, based on the derivative part of it, not on the values part. So you should remember this as well. Now it is minus 2.18 into 10 to the power minus 18 z square by n square joules per atom. Please do focus on the units here. Energy given here as minus 2.18 into 10 power minus 18 joules per atom, z square by n square. Everywhere you see z square by n square. Energy is z square by n square. Radius is n square by z. Radius is 0.529 times n square by z, and energy will be minus 2.18 into 10 power minus 18 z square by n square. Here also z square by n square. Here also z square by n square. Here also z square by n square. Everywhere you see this z square by n square, and kilojoules per mole you have. Per mole is what? If it is per mole, for 1 mole of atoms. But in questions generally you will be asked per atom, then you use that. Per mole you use this minus 1312 into z square by n square, or if it is given to you in electron volts, then you can use it as 1 minus 13.6 into z square by n square electron volts. And now what is electron volt? You can write this also here. I have given you the conversion of the electron volt also. 1.6 into 10 to the power minus 19 joules is 1 electron volt. And potential energy formula we have, kinetic energy formula we have. Potential is minus 27.2 into z square by n square. Kinetic is minus 13.6 z square by n square. Everywhere z square by n square. Energy z square by n square. Remember that. And potential energy is 2 times kinetic energy. You should remember this as well. Potential energy is 2 times kinetic energy. Now you have the energy के लिए electron volts में, it is minus 13.6 times z square by n square. In case n is equal to 1 for the first orbit, n is equal to 1, it is 1 square by 1 square. This is for the hydrogen atom we are talking about. So z square is anyway 1. If it is for the second orbit, E2 minus 13.6 into 1 by 2 square. So which is minus 3.4. If it is 3, 1 by 3 square, which is 4, 1 by 4 square. These are the approximate values what we have in electron volts. And the seventh set here is velocity of the electron in the nth orbit. Velocity in the nth orbit is 2.18 into 10 to the power 16 z by n. Energy is z square by n square. Velocity is z by n. Remember, z by n. Velocity is z by n times 2.18 into 10 to the power minus 16. Then you have the next set of questions here as delta E is equals to h nu, and this we know anyway. H nu is the energy there, and hc by lambda, nothing but delta E. I am making 1 by lambda as my subject because 1 by lambda is my wave number. Wave number is represented by nu bar. Nu bar is wave number, which is delta E by hc. And the value of it is, you have Rydberg's constants 109677 times 1 by an initial square minus final square times z square, because it is energy there. So z square by n square, it is perfectly, it has to be there, and the delta energy, so that would be the change, final minus initial square, right? So that would be your this question value, this value. And number of emission lines, as we talk about it, is n2 minus n1 times n2 minus n1 plus 1, or delta n into delta n plus 1 by 2. this one. So delta n is always n2 minus n1. And number of revolutions made by electron around the nucleus, if we talk about that, number of revolutions is velocity by circumference. How will we get that? See, we know again speed is distance by time. So speed by distance is 1 by time, and 1 by time is frequency. And what is frequency? Frequency is nothing but the number of revolutions. Okay, and speed is velocity we talk about, and distance around it, around the nucleus, it is 2 pi r. 2 pi r is something around the nucleus, which is nothing but the circumference, right? That is what we have written. V by 2 pi r is the number of revolutions made, right? And for this, if I have to talk about specifically about the particular atom, 2 pi mv by h square into z square by n square, z square by n square. Okay, so do remember these formulations, and this is it. This is the only formula what we have in your chapter atomic structure, wherein you can use these things only to bring out only this much, bacha, nothing else. You have only and only this much. So once we are done with this, please, I hope you have written everything right. Now we are going to do the questions, your JEE questions. I will make you do the JEE questions. I want you to try your MSET questions and come back to me with any doubts that you have. All right. So let's start JEE main previous year questions now. Yes, Bache. So now let's discuss about the PYQs of JEE mains. Okay, which of the following ions have the maximum magnetic moment? What do you mean by magnetic moment? Under root n of n plus 2. Please write it down in your book as well. Under root n into n plus 2 is magnetic moment, which is considered to be your mu. Is n stands for number of unpaired electrons. And what are the unpaired electrons? If I have to talk about manganese, manganese plus 2, manganese plus 2 is argon, and plus 2, which means 2 electrons went off, which means S has gone, and then 3d5. This is 25 now. So 25, it is 18, and 2 went off, which is 20 done, and then 5. Then Fe plus 2 you have, we talk about Fe plus 2. Fe plus 2 is argon, and then S went off, 2 electrons went off, and then 20 done. It is 3d6 now. And then titanium plus 2, it is argon, 2 went off, and then 3d2. And then chromium plus 2 is argon, 2 went off, and then 3d4. So this will be your configuration in which is having the most number of unpaired electrons. Here you have manganese D5. D5 stands for 5 unpaired electrons. So 1 2 3 4 5 d orbital you have, right? 1 2 3 4 5. 5 unpaired electrons is the maximum. 5 times 5 plus 2, which is 5 times 7 under root, which will be the most for this. And according to the Bohr's theory, the angular momentum of a electron in the fifth orbit is, angular momentum formula is nh by 2 pi, right? Angular momentum we've already written, mvr is equal to nh by 2 pi. So just substitute that. Fifth orbit, n stands to be 5. So 5 by 2, 5 by 2 is 2.5 into h by pi. Then you have uncertainty in the position of an electron. Uncertainty in the position of electron of mass is given to you, and moving with a velocity of 300 meters per second. So will be accurately up to 0.001%, they say, which means your velocity is what? 0.001% of the velocity, this one, right? So calculate it now. This will be your 0.001%, which is 1 by 1000 into 1 by 100 into 300 meters per second, right? So the uncertainty in this position should be how much? So you are asking about, you have been asked about delta x there. So we have delta v. This is my delta v value. Delta v value is this much, which is 3 into 10 to the power minus 3, and greater than or equal to h by 4 pi. As I have told you already, h by 4 pi value, it is always 0.52 times your given to you there. So please check out your values there, Nana. So always be sure of those values, because these are the values which you will be using it for a long time, right? So h by 4 pi value can be redefined. It's not writing. Once again. One second, yeah. 0.52 times 10 to the power minus 34. This value you put and substitute, you will get your answer there. All right. Then moving on with the next question there. Which of the following set of quantum numbers is correct for an electron in 4f orbital? 4f, which means n is equal to 4, correct, n equals to 4, n equals to 4, n equals to 4, correct. If n equals to 4, yes, L can be 3. So L is 4, not right. So L can be 3, correct. And then M can be plus 4, no, because M values always range from minus L to plus L only. So minus 3 to plus 3 only, M cannot be 4. So obviously C is my answer there. Then which of the following sets of quantum number represents the highest energy? Highest energy is always N plus L rule. So whichever's value of N plus L is more, that will be your answer. N plus L, 3 plus 2, 5. So this is your answer there, done. Next, moving on, ionization enthalpies or nothing but that energy required to remove an electron into the excited state and all, right? Yes, ionization enthalpy of hydrogen is given to you as this much, and itna joules per mole is given to you. And the energy required to excite it, in the atom from n equals to 1 to the fourth state. So which means this is nothing but your ionization enthalpy, which is 1.312 into 10 to the power 6 into 1 by 4, 1 by 1 minus 1 by 4, right? 1 by 1 square minus 1 by 2 square, which is 4, which is 3 by 2 times all the 3 by 4 times all this value. That's going to be your 9.84. So just substitute the values and check, you would get the values there. And everything is joules per mole, you don't need to convert it. So this is the thing. Then you have in an atom, an electron is moving with a speed of 600 meters per second with an accuracy of this, which means again, I want you to go with delta V value, same question like the previous one. Delta V is equal to 0.005%, matlab 5 by 1000 into percent, matlab 1 by 100 of 600. So this gone, 30 by 1000, which is 3 by 100, which is 3 into 10 to the power minus 2 is my delta V value. And you have your this part, delta X is asked to you, H by 4 pi. We do have that 0.52 into 10 to the power minus 34. 0.52 into 10 to the power minus 34 is this value, divided by 3.3 into 10 to the power minus 2. That will give you this answer. I'm not doing that calculative part. You would do that. I'm just bringing you the base relation. I'm leaving it here. Now, in case I'm going a little bit faster, please pause the video and note it down. All right. Yes. Moving on, I want you to do the calculative part, bacha. Don't skip the calculative part because in exam, you have to play. All right. Next, calculate the wavelength in the nanometer associated with a proton moving at this much and given to you. So wavelength, lambda is de Broglie's wavelength is h by p, right? H by p. P stands for mass into velocity. Just substitute h value. You have 6.63 given to you. Take that only. Mass is given to you 1.67 into 10 power minus 27. Also take that. Okay, so you just have to substitute that values there. And velocity, if it is given to you, yes, it is given to us 1 into 10 power minus 10 power 3. It is given to us. Just substitute those values. You are going to get this value there. Next, energy required to break 1 mole of chlorine bonds is 242 kilojoules per mole. And we are talking about not per mole there. So I would say here the energy here is your initially divided by 242, I would say kilojoules. Now I would write it as 242 into 1000. This is the kilojoules. I have converted into joules per mole. So divided by Avogadro number. Avogadro number is 6.62, 6.022 into 10 to the power minus 20, 10 to the power 23. So as you put that value, you will get the value of energy there per atom you will get. And HC value we already know, which is 2 into 10 to the power minus 25. So lambda is equal to 2 into 10 power minus 25 by all this star value, what you're going to get. So that will be giving your answer there. All right, so you calculate the answer and check out your answer from your textbooks as well. Next, moving on, E is equal to hc by lambda. We know that, right? E is equal to h nu or hc by lambda, whatever it is. Next, moving on with the next question. Ionization energy of helium is 19.6 into 10 to the power minus 18 given to us. And energy of the first state of the lithium plus 2 ion is asked to you. So E is equal to energy is given, ionization of helium is given to you. Na? So I would say ionization of hydrogen to ionization of helium, or in case lithium, sorry, in case lithium is asked to you, take the lithium as the numerator, no problem. Ionization energy of lithium by energy of hydrogen. Okay, lithium by hydrogen. Lithium's energy is what we do not know. Energy formula is what? 13 point, how much is that? Because is that given to you in electron volts and all? I guess not. It is not given in electron volts, that whichever it is. So minus 13.6 Z square by N square is your energy formula. So minus 13.6 in the numerator and denominator gets cancelled. It is Z square by N square. Z for lithium will be your 3. Z is 3, na atomic number, it is 3. 3 square, which will be 9 by N square. N square is what? It is your first orbit only, I guess. I hope it is not given. Ionization energy of the first state, yeah, of the first state only. So it will be 1 only by your helium. Helium is 4 by 1. Helium comes at number 2 in the periodic table. Z square is 4, which is 2 square. So now whatever you get here, this is lithium ka pucha gaya, so 9 by 4 times energy of the helium, and which is 19.6 into 10 to the power minus 18. So this is going to get you the answer there. 9 by 4 times the 19.6. That will give you the answer. That's it. So let's move on to the next set of questions there. Yeah. I hope you can see it well here. Outermost configuration of atomic number 64. Atomic number 64. Xenon, you would write. Xenon is 54. And then 6s2. 54 plus 2, 56 done. And then what? This is 4f8, right? 54 plus 2, 56. 56 plus 8 is 64 done. But what happens here is exactly F7 is half filled, right? F has got 7 boxes and 7 is half filled, 14 is fulfilled. Any element tries to achieve the noble gas configuration or a stable configuration, whichever stable configuration it is. It can be half filled or it can be fulfilled configurations. So to attain a fulfilled configuration, it has to go with 1 electron should get transferred. So it is 4f7 and then 5d1. And so this will be 4f7, 5d1 and 6s2. This would be for your GD. All right. Then gadolinium, GD is gadolinium. Next, number 12, a gas absorbs a photon of 355 nanometer and emits 2 wavelengths. So 1 by lambda is, please note it down in your formula page. 1 by lambda equals to 1 by lambda is 1 by lambda 1 plus 1 by lambda 2. This is another formula. All right, so or hc by lambda, I would say nothing, but hc by lambda, energy is hc by lambda kada. So the two energies sum is equal to the total energy. So E is equal to hc by lambda 1 plus hc by lambda 2, which is hc by lambda, hc common. So 1 by energy absorbs 355, right? So then it comes up with 1 second. So 1 by lambda, lambda is given to you as 355, right? All nanometers, you don't need to convert, bacha, is equal to 1 by lambda 1 is given to you as 680 nanometers. It is not printed there, bacha. It is 680 nanometers plus 1 by lambda 2. So from here, you can bring out the lambda 2 value. 1 by lambda 2 is equal to 1 by 680 minus 1 by 355. Solve it, you will get your answer there. Next, 13. Electrons identified by quantum numbers n and l. N equals to 4, l equals to 1. All these given to energies के बारे में. Energy is n plus l rule. Energy पूछा गया, so it has to be always n plus l rule. So if it is n plus l, what is n plus l? 4 plus 1 is 5 here. 4 plus 0 is 4 here. 3 plus 2 is 5 here. 3 plus 1 is 4 here. So in this also, whichever is at the biggest energy, highest energy is n value big. N value, whosoever n value is bigger value is of the bigger energy. So therefore, in that case, I would talk about the increasing energies of the order. Here, A has got the highest. N is equal to 4 here. N equals to 3 here. As I'm underlining here, N equals to 4 and N equals to 3. N equals to 4 is the bigger value. So A is the bigger one. And then C. Then in your B and D also, as you see B and D also, N value only focus. N equals to 4, N equals to 3. N equals to 4 is bigger value. So B and this. So this will be your option B there. Right? So you can eliminate the options in that manner as well. Next question number 14, the de Broglie's wavelength. De Broglie wavelength is lambda is equal to h by p, and h by p stands for mass into velocity. Now velocity is 36 kilometer per hour. Don't accept that. That is 36 into 5 by 18. 18 ones, 18 twos. It is 10 meters per second. So velocity is 10 meters per second. H value is 6.626 into 10, or given to you, whatever given to you, will use that only. 6.63 into 10 power minus 34 is given to us there. That will be there. And mass is 1000 kilograms. When you put that, you are going to get this value there. All right. So moving up. Next, 1 second. Keep doing the next question. Yes, question number 15 there. Given n equals to 5, m equals to 1, and something here. You're given one set here and another set here. Now, the maximum number of electrons in an atom that can have the quantum numbers as given. You are asked about the number of electrons there. So, number of electrons for the second question, if I say n equals to 2, L is given to you, M is given to you, and spin is minus half. And there will be unique set of values for 4 values will be unique for each and every electron. So therefore, it is only one electron, one electron, one electron, one electron. So you have 3 options there. Now we talk about the first question. So in case generally, in case something given to you like this, your option will be in these 3 only because it is more probable given there. Or as I told you, the main reason for this is n values, n, l, m, and spin quantum numbers values, if they are given, it will be only and only for one electron, unique values given to you. And next, coming up for the first part, n equals to 5. If n equals to 5, L values are 0, 1, 2, 3, 4. As you can see my cursor moving here, L values are 0, 1, 2, 3, 4. And what are your m values? M always ranges from minus L to plus L. Minus L to plus L, which is m equals to 1 ante here 0 ke liye to it is impossible na, minus 0 to plus 0. You will not get the value of 1 there. And for n equals to 1 here, m value is minus 1 to plus 1. Here you will have plus 1 value. And this is m value talks about your orbital values. Orbital values. And each orbital has got 2 electrons. If m equals to 1, it is 2 electrons. 2, it is 2 electrons. 3, 2 electrons. 4, it is 2 electrons. Totally 8 electrons. So option B is your answer there. Next, question number 16, wave number for the first emission line in the Balmer series. Balmer series is n equals to 2 and final is 3. All right. So initial is 2, n equals to 2 on, because Balmer series, Lyman, Balmer, Passion, Fund. So a bracket fund, all these starts, n equals to 1 is Lyman, n equals to 2 is Balmer. So from 2 onwards, the first emission, matlab, the final one is your 3 only. First emission from the 2 to the 3, right? Only the first emission. Emission spectrum, not absorption. This is emission. So and final is your 3 there. So now in the hydrogen spectrum, nu bar is nothing but your wave number, which is 1 by lambda, which is equal to R times 1 by n initial square minus 1 by n final square, R times 1 by 4 minus 1 by 9. 9 minus 4, 5 by 36. 5 by 36, R, which is your option A there, right? See, these are all the JEE questions which have come up, but it is easy when you go with your formulae ready. It has to be, you have to be always ready with your formulations on the go, Anmata. Okay, next, in an atom, how many orbitals will have the quantum number? See, 3, 2, how many orbitals will have the quantum number? This. See, 3 sets are given to you there, and orbital value is +2 is given to you. That will be a fixed value only, +2 value only for one orbital. If they ask you how many electrons, it is one orbital, therefore 2 electrons. You can say each orbital consists of 2 electrons there, nice. Next, coming up with the question number 18 there. Energy of an electron is given by E is equal to this much wavelength. You should remember this, bacha, 2.18. What we are taking, minus 2.18 into 10 power minus 18 Z square by N square. Even if it is not given to you, you should know that. Now, wavelength of the light required for this spectrum from 1 to 2 is, so first 1 to 2 anangane, I have to go with what is the energy change. Energy change is Z square by N initial square and final square minus N initial square, which is 1 by 1 minus 1 by 4, which is 3 by 4 times. This is 3 by 4 times 2.18 into 10 to the power minus 18. This will be your energy, right? This is your energy, what we are getting there. But what is that we are asked about completely? We are now asked about your, which is the question we are doing? Yeah, yes. So wavelength is being asked to us. Wavelength is what? E is equal to hc by lambda, right? E is equal to hc by lambda. So lambda is equal to hc by E. Hc value we know, which is 2 into 10 to the power minus 25 by E value. E value is this, Nana. All this star value, what I'm using there is my E value. When you substitute it here, you are going to get your answer there. All right. So that is how we will do this question. And then coming up with the next one, question number 19, the energy of an electron in the first Bohr orbit is 13.6. The energy of electron in the excited state of lithium. Excited state of lithium is nothing but that first excited state of lithium. If you want to talk about, then it is 1 by 1 square. See, it is, your this energy, which is minus 13.6 into 1 minus 1 by 4. It is 1 by 1 minus 1 by 2 square. 1 by n initial square minus 1 by 1 n final square. It is 1 by 1 minus 1 by 2 square, which is nothing but 4 minus 1, which is 3 by 4 times this value. So, which is your value of this part here is going to be whichever the value is. Please check it out. You do the calculation and check out the value there. You will get that. Next, moving up. Question number 20 there. If lambda naught and lambda be the threshold wavelength and threshold wavelength of the incident lights, the velocity of the photon ejected from the metal surface is. So what is that asked to you? It is nothing but your photoelectric effect question. This is right. So what is the velocity of the electron photon ejected, which is C h nu is equal to h nu naught plus kinetic energy. Now we are asked about kinetic energy is equal to what? Like velocity is asked to you. Let me fix my kinetic energy first, which is h nu naught minus h nu, which is h of nu naught minus nu. Now Kinetic energy is half m v square. So v square is equal to 2h by m times nu naught minus nu. Now v is equal to under root of all this. Now under root 2h by m times nu naught minus nu, which is your option B, I guess, right? So that's how you can do. Next question number 21. De Broglie's wavelength of a particle of mass 6.63 grams moving with a velocity of this. De Broglie wavelength is lambda is equal to h by p, which is h by mass into velocity, right? And h is what? We already know that 6.626 into 10 to the power minus 34 by mass of it is 6.63 grams. 6.63 grams into velocity is 100. You can just calculate that. You will get your value there. So please do the calculations as we are doing. Pause it and do the. Next, coming up with the next set of questions. Question number 22. Ionization energy of gaseous sodium atoms is given to you kilojoules per mole. We don't want this per mole here because the answer is not in per mole or something. So these many kilojoules per mole, you will convert it. Okay, 495.5 kilojoules, it is into 10 power 3 per mole, right? It is so divided by Avogadro number. So this one will be your energy. See, E is equal to h nu. We know we are asked about the frequencies. So nu is equal to E by h. E is all this divided by h. H is 6.625 into 10 power minus 34. You do that, you will get the answer there. Next question, the correct set of 4 quantum numbers for the valence electrons on rubidium, which is 37. Rubidium comes at krypton and krypton is 36. After 36, then it goes to 5s1, right? So which is your n value is 5 here, right? If n is equal to 5, s, p, d, f, 0, 1, 2, 3. Please do remember this. S is 0. So n is equal to 5, L is equal to 0. If L is equal to 0, M also will be 0 because M values go with minus L to plus L. So M is also 0 here. Then 5, 0, 0, that's it. You got your answer and half here, right? Because spin quantum is always either plus half or minus half depending on which electron it is, how many electrons you have there, right? And now question number 24. Which of the following is the energy of a possible excited state of hydrogen? Hydro energy is what everything is given to you in electron volts. Energy is minus 13.6 into Z square by N. Energy is always Z square by N square. We have already discussed that. And which of this is the possible excited state value? If N equals to 1, Z hydrogen bola to Z is 1 only. I can remove this. So 13.6 by 1 square, 13.6 by 2 square, 13.6 by 3 square go. So 13.6 by 2 square, which is 4, is your option C there. So this will be your possible value there. So you just have to hit and trial there. So put on the values of N values and bring out the numbers there. Next, the principal quantum N is equal to 6. If n is the sixth series, you will have your, which is sixth row, sixth horizontal row in your periodic table will have your f orbitals as well. Now, if you have f orbitals, general configuration is ns and then n minus 2f, then n minus 1d, and then np, ns, np, right? Then n minus 2f, n minus 1d. This is your standard configuration. Next, moving up with 26 there. A stream of electrons from heated element, a filament, was passed between two charged plates kept at the potential difference V. Then if E and M are the charges given to you there, then what will be you're talking about? Then the value of H by lambda is asked to you. Lambda is equal to H by under root 2m QV. This we already know. Just substitute it there, right? Lambda values we have written there. We have in your formula page. Please open up your formula page and check out the values there. Okay, lambda is equal to H by under root 2mq and V, or I would say under root 2mev is equal to H by lambda. Okay, from here you can get those values. H by lambda is nothing but under root 2 MeV direct, right? Next, the total number of orbitals associated with the principal quantum number 5. If n is equal to 5, we know that it is 2n square. This is on your question. This question is based on your ninth standard, I would say. Yeah. See, number of electrons in a given orbit, where n stands for the number of the orbit, right? It is 2n square number of electrons, but we are asked about the number of orbitals here. One orbital has got 2 electrons, so therefore half of it, which means n square. N is 5, so 25. Next, the radius of the third Bohr's orbit of hydrogen atom is R3 and the radius of fourth orbit is R4. So just do R3 by R4. That's it. You would get your answer there. Right, what is R3 by R4? R3 by R4 is 0.5293 square by hydrogen square, which we don't need to write by hydrogen, which we don't need to write that. 0.5293 square by 0.5294 square, which is nothing but 9 by 16. 9 by 16. So R3 is equal to 4 times 9 by 16. Right? R4 times 9 by 16. Or R4 is equal to 16 R3 by 9, whichever it is. Right? Next. Coming up with the next one, 29. The minimum energy that must be possessed by photons in order to produce the photoelectric effect is the threshold frequency, right? The threshold frequency, and the corresponding energy will be your threshold energy there. Right? Now, coming up with that, where is that? Yeah, minimum energy that must be possessed by photon in order to produce the photoelectric effect with platinum, which means I would say work function is equal to your h nu naught. Let us find that. H nu is the energy, na? So threshold frequency is not is asked to you. So h into nu naught, that's it. You just substitute the values. You have h, you have nu naught, done. Your answer done. Next. Coming up with the next one, radius of the second orbit in the terms of Bohr's radius A naught in lithium is asked to you. So lithium radius is nothing but your A naught time n square by z kata. So in which orbit is that? Your second orbit? Second orbit. Yeah, second orbit, then definitely n is equal to 2. So A naught times 4 by Z value for lithium is 3. So 4 A naught by 3 becomes your answer there, option C. Next, coming up with the next question, the ratio of the shortest wavelength to the spectral of two spectral lengths. See, every time remember that, bacha, shortest wavelength matlab highest transition. Highest transition will be for n is equal to infinity. 1n is infinity, two spectral lines are there, is found to be 9, which means ratio is found to be 9, right? So it has to, we will check it up. Lyman to Paschen, let us check. Lyman to Paschen is, as you can see, 1 by lambda of Lyman, 1 by lambda of Paschen, which is r into 1. Lyman ke liye 1 by 1 minus 1 by infinity square, and Paschen ke liye n is equal to 3 onwards, na? So as is n equals to 3 onward, n starts from 3 onwards, 1 by 3 square minus infinity. When you divide these two, r and r gets cancelled. Nu by nu of Lyman by nu of Paschen is 9 by 1. And that is what it is, Lyman and Paschen here, right? Paschen series. So always go with your hit and trial methods of your series. Yes, now the ground state energy of hydrogen atom is given to you here, which is minus 13.6 electron volts. Energy of the second excited state. Second excited state. First excited state is n equals to 2. Ground state is 1. Na? Second excited state is n equals to 3 for the helium, right? Second excited state is n equals to 3 for the helium. First excited state is n equals to 2. Second excited state is n equals to 3. For helium, energy is what? 13.6 Z square by N square. So minus 13.6 Z square by N square. Z stands for atomic number. Atomic number for helium is 2. Therefore, it is 4 Z square by N square. Done. So this calculation will give you the answer. Then ejection of proton from metal in the photoelectric effect experiment can be stopped by applying 0.5 volts when the radiation of 250 nanometer is used. Work function of the metal is, whenever it is talking about the work function, you will be talking about h nu is equal to h nu naught, or h nu naught is or h nu is equal to, I will first give you this information only on this. One second. Yeah. H nu is equal to h nu naught plus half mv square. So here work function is being asked to us. So therefore this is being asked to us, h nu minus half mv square. Just substitute those values, you will get your answer there. All right. Or I would say for that, first immediately you will bring out your h nu naught value, which is energy is hc by lambda. No? So for this part, I would write it here, hc by lambda, which is hc is 2 into 10 to the power minus 25 by lambda value. Lambda value is 250 nanometers. 250 into 10 to the power minus 9. The nanometer is 10 power minus 9, which here you are going to get this as 0.0125, something that way. Okay, so that values you will get, and you will just substitute it here. You will get this answer there. And whatever you are getting here is, you have to convert it into electron volts. Then you have to divide. This is the joules what you get. No? 1 joule or 1 electron volt is 10 to the power minus, so 6.1 into 1 second. Yeah. So one electron volt is 1.6 into 10 to the power minus 19 joules. So these many joules is that by 1.6 into 10 to the power minus 19, wherein you get one answer there. And then that minus 0.5, 0.5 minus this, what you get is your answer there. So just substitute those values, calculations. I'm leaving it up to you, but do the calculations. I'm doing all the skeleton work for you. You will do the calculations at home very fast. Okay. Next. Question number 34 we are in. The electron in the energy in the hydrogen atom undergoes transition from higher orbital to the orbital of radius 211.6. 211.6 is the radius there. The transition is associated with which series? It has been asked to us. So radius of the nth orbit is 0.529 n square by z. Right? So now it is hydrogen. So Z is equal to 1. Radius is given to you. So radius is what? 2.211.6 picometer is 10 to the power minus 12 by 0.529 into, this is angstrom, so into 10 power minus 10 is your n square. This will be roughly somewhere around your 4. So n square is equal to 4, n is equal to 2. If n is equal to 2, it is your Balmer series. N equals to 2 is your Balmer series. Next, moving on with the 35, question number 35 here. Given below are some statements. According to the Bohr's model of an atom, qualitatively, the magnitude of the velocity of electron increases with decrease in the positive charge on the nucleus. Is that right? See, magnitude of the velocity increases with the increase in the positive charge of the nucleus, right? So therefore, it is wrong. According to the Bohr's model of an atom, qualitatively, the magnitude of the velocity of the electron increases with the decrease in the principal quantum number. Yes, as the principal quantum number is getting decreased, velocity of the electron is increasing because the charge on it is much closer. So there will be lot of attraction there. So lot of momentum gained by it. So therefore, the movement is happening. So statement 1 is wrong and statement 2 is right. Then question number 36. Moving on to question number 36. Energy of 1 mole of photons of radiation of wavelength 300 nanometer is given to you. Lambda is given to you and you're asked about energy. Energy is what? Hc by lambda. Hc value we know. See, energy is Hc by lambda. It has to be in your mind right now. Okay, Hc is 2 into 10 to the power minus 25. So remember that also Hc value is a fixed value what we can use. By lambda is 300. Nanometer is given to you 10 to the power minus 9. Mat bhulo. So that will give you the answer there. And here, what else is given to you? Some Avogadro number is also given to you. Energy of 1 mole is given to you, asked to you. This is for one atom, right? One. but your energy of 1 mole, which means into Avogadro number, which is 6.022 into 10 to the power 23. So when you multiply that, you will get your answer there. Now, 37. The de Broglie wavelength of an electron in the hydrogen atom in the fourth orbit. De Broglie wavelength is what? Lambda is equal to h by mc. So bring the value there and then substitute. So, and we also know that 2 pi r is equal to n lambda, na? 2 pi r is equal to n lambda, n into lambda. Yeah, one second. Yeah, n into lambda. And just substitute those values there. You are going to get that part here. Right? Then 38, if the de Broglie wavelength of the electron in the nth Bohr orbit of a hydrogen atom is equal to 1.5 pi a naught is given to us. So radius we know as a naught times n square by z then, right? And we know that n pi, n lambda or else is equal to 2 pi r. So with this we can do it, right? So hc by lambda a naught into n square by z. Yeah, so as you substitute the n square by z value, you will get that values nana fourth Bohr's orbit bola hai, so just substitute that, and hydrogen atom bola hai, bring it up, that's it. Next, moving on. Just a second. So fourth Bohr's orbit, I hope this is, no, sorry, we are on 38th, right? Yeah. So you are given here lambda is equal to de Broglie's wavelength is given by this. So lambda is given to you as 1.5 pi a naught. Just a second, it's not writing. Yeah. 1.5 pi a naught. Why, right? 1.5 pi a naught. Yeah. So that is the value of the lambda given to us, and we know radius, which as a n square by z, right? So therefore, I would say here, we know the value of n lambda is equal to 2 pi r, or lambda is equal to 2 pi r by n. That's also, we have a formula there written, right? So n pi is equal to 2 pi r, 2 pi into, in the place of r, I am using this. In the place of r, I would be using a naught into n square by z. So this n square, n cuts here, n cuts there, and 1.5 pi a naught ke jagah pe, a naught is equal to 2 pi a naught by z, right? So this pi and this pi gets cancelled off. So you can just bring out that there, right? So that is how finally you will get the answer. So which is 38th question is done. Then you get some 0.75 there, the values, Nana. You can just keep doing that. You will get that value there. Next, moving on to the next question here. 39, I guess. Yeah. The de Broglie wavelength lambda associated with a photoelectron varies with the frequency V and of the incident radiations. So it varies, bola na. So then what should we write there? H of V minus V naught is equal to half mv square. Or where did I get that from? Chalo, let me go with a detailed thing only. H nu is equal to H nu naught plus half mv square, right? This is what we know. So in that case, half mv square is equal to h nu minus h nu naught minus h nu, which is h of nu naught minus nu there. So then I would write nu naught minus nu is equal to 1 by 2h into mv square, right? So which means nu minus nu naught is directly proportional to v square. It is directly proportional to v square. So under root of this is directly proportional to v. So therefore here 1 by lambda is inversely proportional to 1 by v minus v naught the square, which is your option D here. Yeah. Square root karna hai na, so which is your option D. Then number 40, the last one here, de Broglie's wavelength of an electron present in the first Bohr's orbit of hydrogen atom is, which is nothing but your 2 pi r you go with, yeah, 2 pi r, right? So 2 pi radius is 0.529 angstrom units, right? So that will be your answer there. That's it then. Chalo. So I'll give you some more questions also now. 1 second. Yes, let's do some of these questions as well in your first exercise, I guess. These are from your first exercise. In the following reaction, lithium plus 6 plus how much will be 2 helium plus this. So as you can see here, 3 and 2 plus 1, 3 set. Next, here is what? 4 plus 3, which is your 7 on the right side mass and 6 on the left side mass. So it has to be one mass and then it has to be my neutron with 0, right? Neutron is 0 and with one mass, because 6 plus 1, 7, you're going to get that thing well there, right? So balancing the equation is important there. Next, number 2, increasing order of the lowest first for the magnitude of Q by M ratio. Charge by mass ratio is what? For the electrons, right? So charge by mass for the electron. Mass for the electron is very negligible. Proton mass is good enough. Neutron charge is very much negligible. See, this we are talking about for electron, proton, neutron, and alpha. Charge by mass ratio. Charge of an electron is 1.6 into 10 to the power minus 19 by electron mass is 9.1 into 10 to the power minus 31. Proton is 1.6 into 10 to the power minus 19 by 1.6 into 10 to the power minus 27. Neutron is a charge by mass 0 by whatever it is, answer 0. And then alpha particle is 2 protons plus 2 neutrons. And it is plus 2 charge, which is 2 into 1.6 into 10 to the power minus 19. 2 plus 2 charge kada. Alpha is nothing but always 2 proton plus 2 neutron. This is your alpha. So, which is 4 mass, na? Charge by mass ratio. Charge, neutron will not have any charge. Charge of proton is 2 by your mass. Mass is 4, right? 4 of proton. 4 of each proton is mass. Here is 1.6 into 10 to the power minus 27. Now you put them in order. This is what you get. Right, and neutron will have the least, right? Increasing order matlab least one you have to go with. So neutron is the least here. Then you have your alpha, because you have 2 into this by this. This is 1 by 2 times this, no? So half of this. So you just compare it and think. Next, number 3, x minus 2 has 56 electrons. Atomic number of x is what? X minus 2, which means 2 electrons more than 56. The actual has to be 54 only, no? So 54, 2 electrons more if it is there, it is 56. But the original one will be 54 then. Next, question number 4, 11 and 23, magnesium, this are called as what? They are not your isotopes. Are they your isobars? No, because no mass is not the same. So not the isobars. Not the isotopes, because atomic numbers are different here. Then you have isotones. Let us check if they are isotones. Neutrons for sodium and neutrons for magnesium. Neutrons for sodium is 23 minus 11, which is 12, and 24 minus 12, which is again 12. So therefore they are isotones. Isotones will have the same neutron number. Okay. And now going up with the next question. Question number 5 here. 1 second, Macha. Oh. Keep doing the next question. Yeah. Now, particle in cathode ray has same charge by mass ratio as the particle of what? As the beta particle, I would say. cathode ray is nothing but electron, and beta particle is an electron coming out of the nucleus. And number 6, during Millikan's oil drop experiment of the following, which is not a possible charge of this. So we have Q is equal to N into E. Randomly go with N equals to 1, N equals to 2, N equals to 3, N equals to 4. It goes on, right? 1 into 1.6, yes it is. 2 into 1.6, yes it is. 3 into 1.6, yes it is. This is not, so therefore this is my answer. So that is how you will go. Next. Next question in your books. Please keep doing it in your books as I'm moving the page here. The next question here, in a time period of 2 seconds is given to us. It is time period is 2 seconds given to us now. Oh, I don't know what is happening to this. 1 second. Yeah. Yes. So now time period is 2 seconds here, right? So if time period is 2 seconds, what will be your frequency? Frequency is 1 by 2, right? And then the frequency of the wave, time period is 2 seconds, following wave pattern is observed. Frequency would be 1 by 2 there, right? Then moving on to the next one, just a second. Next question. Yellow light is more energetic than yellow light is more energy. Higher energy, it is less frequency. Less frequency, more wavelength, right? So you go on with this red here because as compared to the yellow, everything else has got the more frequency. Least frequency is for the red, which means less number of turns per second, number of vibrations or number of oscillations per second is less for the red, because red is the most fastest traveling color. Next, moving on with the question number 9. Rutherford's experiment on scattering of alpha particles showed for the first time that atom has a nucleus. Yes, wave number of radiation of the wavelength 500 nanometer. Wave number, nu bar, is 1 by lambda. You will do that. Ratio of the energy of the photon of 2000 angstroms wavelength to the radiation of 4000 angstrom radiation. So what do you mean by energies? Energy is E is equal to hc by lambda. So definitely your this is E is equal to, or lambda is equal to hc by E. Just do a ratio there, you will get that value. Then moving on with the next question. Then you have, yeah, 1 second. Let me move the page now. Also, yes, bacha. So here, as we have, I think this is ratio only, na? Hc by lambda 1 by hc by lambda 2, which is lambda 2 by lambda 1, which you get the answer there, 4000 by 2000. Then question number 12, what you have here is Radio City broadcast the frequencies of 5090 kilohertz given to you. So kilohertz, you will convert it 5090 into 10 power 3 hertz, which means you are given the frequency and what is the wavelength, it has been asked to you. So nu is equal to c by lambda. Just put the value there, you will get that. Okay. Or E is equal to nh nu, which is the next page. 1 second. So just, I think all this first exercise and second exercise is more of the same type. So I want you to go through them. Please do come back to me, as we have done some of these questions from the JEE part, almost 40 to 50 questions we have done from the JEE part. In case you have any doubts in them, you will come back to me on that. I think we can go with another recording as well. For the next set of the questions once you finish this and come back to me. All right. Chalo. Bye, bacha. Then see you.